Hey guys, this is a quick video for homework 7, week of February 20th. In problem 1, we want to simplify. We want to remove parentheses and make the expression look a little bit shorter. I did a lot more on this topic in the last video, so if you're confused, please see the video for homework 6. But as a quick review, you need to know that 0 exponent, anything to the 0 power is 1. So this one is just 1 times x to the 4th, and there's nothing else you can do, so x to the 4th is the answer simplified. In problem B, you need to know what negative exponents do. Negative exponents should remind you that it has to do with division or taking the reciprocal. So this is just 1 over x to the 5th. The exponent becomes positive when it goes to the denominator. Let's move on. Problem 2, circle if it's exponential or linear and then write the equation. The box here, the chart, is just telling you, reminding you that exponential takes on this form where a is the starting value, b is the common multiplier or ratio, and x, of course, is the exponent. It's also our independent variable. We always want to remember to compare that to linear, which has a slope, and that also has the y-intercept of b. So keep those things in mind. So problem A, a bank account starts with $40 and every week $10 is added. This word added means it's going up by the same amount each time, and that's in a linear fashion. So $10 would be our slope. So it's linear, and we can write y equals mx plus b, and 10 is the slope, it's the rate of change, and b is the starting value, which they give you is 40. In problem B, there are 10,000 polar bears, and every decade the number is halved. When something is divided or multiplied by the same amount each time period, then that is exponential. Let's use our equation, y equals a times b to the x. A is the starting value, 10,000. The b is the amount that it's being multiplied by each time, and when something is halved, it is being multiplied by 1/2. So you can write a half or you can write 0.5 and then to the x power. The next ones are similar. You're going to look for patterns in the table. So for example, in C, we see as x goes up by 1, y is getting cut in half. And that's the same as being multiplied by 1/2. So that equation is pretty similar to part B, except the starting value. Where is the starting value? That's where x is 0. So our equation for this one is going to be y equals 7 times 1/2 to the x. Let's move on to the back side. You want to write the equation for the snow day phone tree. The starting value is right here. It starts with one person being called, and then at every stage it is being multiplied by 3. So times 3, and again, same thing. Y equals starting value of 1, common multiplier is 3, and then to the x power. I think the problem 4 might be a little confusing. This is an exponential decay problem, so we had to figure out by how much is it decreasing each time. And you can see it's going 8,000, 4,000, 2,000, 1,000. So it is similar to what we saw on the front side, that every stage is getting multiplied by 1/2. But what's the starting value? I would go ahead and use this value here. It doesn't say 0, but it says 1910, and that's our first time point, so I would use that one. So starting value is 8,000. The common multiplier is 1/2. And then I'll just simplify it to say it's to the x power, even though that could be up for debate. What is our units on x? Is it 1 year or what? Well, right here it's actually 10 years, so we're going to say x is in decades. Part 5, fill in the table, and I got started and filled in the first one partially for you. You're going to pick several values of x. You're going to show your work in the middle portion of the table, and then your final answer for y is in that right column. So it's just practice on substituting and evaluating. So first I plugged in 0 for x. Anything to the 0 power is 1, so this turns out to be just 3 times 1 equals 3. Let's do the next one. When we plug in 1, 3 times 2 to the first power is 3 times 2, and that's 6. When we plug in 2, 3 times 2 squared is 3 times 4, and that's 12. And the final one, 3 times 2 to the third is 3 times 8, and that's 24. This gives us the opportunity as well to double check that this is exponential. As you can see, 3, 6, 12, 24, those are going up by a factor of 2 each time. Now, you are welcome to choose whatever values of x you would like. So you might want to pick some negatives in there as well.